Hi, welcome to another episode of Science Made Simple. I'm Firhad, and I'm a science specialist here at the Pique Lab. In this video, I'll be analysing a past year examination question from the topic of solutions and suspensions. I've placed the question in a handout, and you may download it for free by clicking on the link in the description box below. So let's begin.
8. A coloured solid is dissolved in 80-degree water until a saturated mixture forms. If you have tried to dissolve Milo or sugar in the kitchen, is it easier to dissolve the solids using hot water or cold water? It is much easier to dissolve using hot water. Why is that? That's because as temperature of water increases, more solids can dissolve in the water, meaning the solubility of the solid increases. Let's write that down. So using this diagram, the solid here is also known as solute. What do we call the beaker of water? We call it solvent. And the resultant mixture form, it can either be a solution or a suspension. When the solids dissolve into the water, are there any undissolved solids left in the mixture? No, the mixture looks the same throughout, or homogeneous. We call this a solution. Let me use an analogy. If students are the solids and water is the classroom, when all solids dissolve in water to form this solution, that is similar to all the students entering the classroom. You can't see the students outside along the corridors anymore, similar to how you don't see any undissolved solids in our beaker. The question says a saturated mixture has formed. So in our case, what is a saturated solution? That means that the maximum amount of solid has dissolved in the water. Let's write that down. Going back to my analogy of students in the classroom, if my classroom can hold a maximum of 40 students, this means that exactly 40 students have entered the class. What happens if we try to squeeze more students into the class? Are they able to get in? No, they can't get in, and I will see them hanging outside at the corridors. Similarly, if I have a saturated solution, can I dissolve any more solids into my saturated solution? No, the extra solids can't dissolve, and I will see the undissolved solids settling at the bottom, just like these extra students waiting in the corridor. So, going back to our saturated solution, what happens if I take this saturated solution that was at 80 degrees and I were to cool it down to 20 degrees Celsius? Usually when we think of cooler temperatures, do substances expand or contract? Substances contract at cooler temperature. So we can use our analogy of the classroom again. Imagine our classroom contracting now. Can it hold more or less students? It can hold less students in the classroom since there is less space. Similarly, at lower temperature, less solids can dissolve in the solution. So does the solubility of the solids increase or decrease? Solubility of the solids decreases at lower temperature. Let's write that down. Imagine now my classroom that originally hold a maximum of 40 students. Now it has shrunk and it can hold a maximum of 10 students. What's going to happen to the 30 kids that don't fit into the classroom? They are going to get kicked out into the corridors. All 30 of them. Similarly, what happens when you cool a saturated solution down to a lower temperature? Since solutes have a lower solubility in cold water, the cooled solution cannot hold as much solute as compared to when it was hot. So the excess solute will be kicked out of the solution and start to form crystals, which will settle to the bottom of the beaker. So we are looking for some solids at the bottom of a beaker of a coloured solution. Let's take a look at our option. Does option 1 show any solid settling at the bottom of our beaker of coloured solution? No, in fact, it just shows a beaker of coloured solution. So this is not our option. What about option 2? Option 2 shows some solids at the bottom of the beaker of a solution. So is this our correct answer? But if you look carefully, it shows all the solids at the bottom of the beaker and none of them dissolved in the water at all. So I'm going to write down here water and I'm going to write down here solids. Using our analogy, this is like all 40 students getting kicked out of the classroom and none of them are in the classroom when we should have at least 10 students in the classroom and 30 students being kicked out. So this eliminates option 2. Does option 3 show some solids at the bottom of a coloured solution? Yes, it does. So this is in fact our correct answer. But let's just take a look at option number 4. This is just a beaker of water. Where are all the solids? The solids have disappeared. Remember our analogy? 30 students are kicked out of the class to the corridors. I should still be able to see those students. They didn't disappear. So option 4 shows no solids at all and the solids have disappeared. This cannot be our answer, and this confirms our answer as option number 3.
Thank you for watching, and I hope you enjoyed this video. If you found this video useful, do give us a thumbs up. If you want to check out the other videos, click on the link on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I see you next time. Bye!